Hello all, welcome back to another video. Today's video will be very exciting as we will be demonstrating how we can bypass the latest fully updated Windows Defender on Windows 11 to achieve a reverse shell connection with Metasploit and MSF Venom. First of all, if you haven't checked out part 1 of the video, please do so. The link will be provided in the video's description. The first part of the video basically covered how we can perform shellcode execution with AES encryption. It is a very quick setup and well-guided setup to follow. Alright, let's get started. What we will be doing is essentially changing the source code that we have already did from part 1 of the video to utilize Dynamic Invoke instead of the current P Invoke. The benefits of using D Invoke is listed on this reference shown in the screen. All credits belong to the authors of the techniques and implementations. We will be showcasing how we can implement the bare minimum D Invoke techniques into our source code manually. So be sure to read through the article here. It is very useful and it covers everything in details with examples. We will not be going through this as it is quite pointless to just read it off from the screen. As explained in the article, P Invoke can be easily detected by AVs and EDRs solutions. Looking at our launcher file, we are using exactly that. By importing the DLL and declaring the functions that we are going to import and use, this will leave a trace in the import address table IAT of the compiled binary. We will be changing all of that in this video as we will implement D Invoke in our launcher file instead. Let's quickly scroll through the article now. There is even a video demonstrating API hooking evasion. The author used the tool API Monitor v2 to demonstrate the evasion. Alright, so reading off here, there is already a project that implements the bare minimum of D Invoke. We want to avoid importing and embedding the whole SharpSploit module as it is unnecessary and may increase the detection surface of our project. Let's check out the example provided here, the NoMC project on GitHub. Okay, so reading through this, what we need to do here is simply to just copy-paste every dinvoke related .cs files so that we can use the dinvoke functions. There are a few here: helper.cs, native.cs, pe.cs, win32.cs, and also in the API directory. Generic.cs, another native.cs, and another win32.cs. We need to take note of the same naming convention used here and avoid it to prevent conflict in our own program. Looking at the second win32.cs file that is in the API directory, we can see that this is where the author creates his own delegates for the dinvoke method of calling virtual protect, for example. We will need to create our own delegates for dinvoke. So how we can do this is to create a new program.cs file as shown in the screen. Let's leave the main method to be something plain first. We will copy the launcher code that we did in part 1 of the video here later on. We will need to copy and paste every CS file mentioned in the NoMC project into this one program.cs file. I have renamed some of the class names such as public class generic to public class gen instead. As mentioned earlier, there are two native.cs files with the same name. The first one will be called the public class n and the second one will be called public class n2. So if you are going to rename some of the public class and function names, you can do so, but you need to take note of it. So it's basically just copying and pasting all the required CS files and making sure that the naming doesn't conflict. This has been done already as shown in the screen. And last but not least, the public class new which I have here is basically the win32.cs file in the API directory. This is where we will need to implement our own delegates for virtual alloc, create thread, and wait for a single object. Alright, Let's take the launcher code that we did together from the first video and paste it into the program.cs main method. We will also need the decrypt function, since the shellcode is AES encrypted, and we will need to decrypt it before we can execute the shellcode in our program. Now, let's implement the necessary delegates for the functions that we need to execute the shellcode. Looking at another resource available from tivara.com, this article has the perfect examples that we are looking for. Let's copy the delegates required and implement it in our code, starting with virtual alloc. Now let's create the necessary repo function for virtual alloc. We can even break up the name of the function that we want to import like this. We can also rename the wrapper function so that there will be no references to virtual alloc in our main method. Let's name it to other alloc. We can now remove the DLL import for virtual alloc, and this will also remove the virtual alloc entry in the import address table of the compiled exe binary. In order to use the other alloc function that we have just created, we need to reference the class name. In this case, it will be new.otheralloc. Let's continue to do the same for the other methods, create thread and wait for a single object. Similarly, let's rename the wrapper functions to create candy and wait for candy instead, to avoid any references to create thread and wait for a single object in our main method. Okay, we should be able to remove the DLL import entries now. Let's change the calling of the functions to add in new dot. This will reference the public class new. Okay, for a quick and simple proof of concept, let's use a MessageBox first. We will switch to a reverse shell later on in the video. Let's generate the shellcode for a MessageBox payload. We can do so using MSF Venom. We will need to AES encrypt the shellcode. Let's use the AES encrypt.cs file that we have done together in the first part of the video. This will output an AES encrypted shellcode that we can use in our program.cs file. Let's compile the AES encrypt CS file with csc.exe. Oh dear, Windows Defender is picking it up. MSF generated shellcode will get detected out of the box. Let's add an exclusion to the folder so that we can get the AES encryptor program working. Let's try to compile the AES encryptor file again. Alright, it works now. Let's execute it and get the AES encrypted shellcode that we can use for our program.cs file. Let's paste it into our program.cs file. Let's compile the program.cs file. Oh no, compilation errors. Let's try and fix it. Alright, I know what is the issue here. Basically, I have renamed quite a few of the class names and function names as well when copying the CS source code from the NoMC project, and I forgot to make the necessary adjustments referencing to the renamed functions and class. So over here, we will need to change the generic to gen instead, since I've renamed it to public class gen. We will also need to rename the dynamic API invoke to how to live alive as shown here that I have renamed it. Okay, let's try to compile it again. Oh no, errors again. This time round it looks easier to fix. It is related to wrong data type. Let's fix them quickly. Okay, looking at this, other alloc should take in the following data types: integer, pointer, integer, integer, integer. Subsequently, let's fix the create thread error also. We will need to make sure that the data type is correctly matched. Okay, this should do it. Let's try and compile it again. It seems that the code address should be of the data type integer pointer. Let's change that. Alright, the compilation works now. Let's execute the program.exe file to see if our dinvoke implementation works. Great, we did it. We managed to implement dinvoke manually into our AES shellcode launcher program. Awesome. Let's create a new payload folder that is not under exclusion to see if this bypasses Windows Defender. Let's move the program file into the created payload folder. This triggered a security scan because cloud detection is enabled on Windows Defender. Let's try to execute it in the payload folder. Awesome, there is no detection despite using MSF Venom generated payload. Now, let's change the payload to a full reverse shell instead of a message box. Let's generate a reverse shell payload with MSF Venom. Now let's paste the reverse shell shellcode into our AES encryptor program to encrypt the shellcode first. Okay, great. Now let's copy the AES encrypted shellcode into our program.cs file. Let's compile the program.cs file now. Program.cs file now contains a MSF Venom generated reverse shell payload that uses dinvoke for the shellcode execution process. Let's move the program.exe into another folder that is not excluded, such as the desktop folder. Oh no, it seems that I have moved the source code.cs file instead. Let's move the exe file. No detections from Windows Defender, that's great. Before we execute, let's set up a listener with MSF console on our Kali. We need to set up the listener for the reverse shell. Alright, this should do it. Let's execute the program.exe file now. As expected, this triggered a security scan as the desktop folder is not excluded. Let's hope this works. Great, we did it! We managed to bypass Windows Defender and obtain a reverse shell connection. We can see that the shell is functional and we can execute commands as well. Now let's try to remove the exclusions entirely and make sure that there are no exclusions at all on the Windows machine. We can also run a scan on the Windows machine after that. That's looking good. No detections at all despite the program.exe file sitting on our desktop directory. Every protection is turned on and our Windows machine is fully updated. There are also no exclusions as shown. Let's try and execute the program.exe again and get a reverse shell. Sweet, we did it. I will be concluding the video here. I hope you all have enjoyed the video. Please help to like the video and subscribe to the channel. It will really help out the channel a lot. Thanks all. All the references used in the video will be in the video's description, so be sure to check them all out. It is important to give them a read to understand how the techniques work, especially this article on the Woover github.io page. I will see you all in the next video. Bye.